7 here. Alright, so the question number 7 reads, evaluate the function at the given values. So I didn't write the values here in my whiteboard, but the values are here. So evaluate the function at the given values of the independent variable, then find a domain and range. So the junior tutor found a domain and range for each of these, I guess A, B, and C, D, but I didn't think that would make sense. So I'm just going to find the domain and the range of this entire function by itself. And this function is special because it's actually a piecewise function. And a piecewise function takes two functions and graphs them on the same graph and gives them separate domains. So if I wanted to explain it any further, whenever the value of x is less than or equal to 1, we're going to use this function. And whenever x is greater than 1, we're going to use this function here. Another thing to note is that the function at x of 1, x equals 1, is not going to be continuous. It's actually going to be discontinuous. There's going to be a jump. So that's something to note too, okay? Alright. Okay, so let's evaluate each of A, B, C, and D. Okay. First, let's evaluate f equals f of negative 2. So f of negative 2, what does that equal? So since negative 2 is less than 1, we're going to use this first function here. So we're going to say negative 2 squared plus 2. So that equals 6. Okay. How about f of 0? Well, f of 0 is always going to be less than 1. So we're going to use this first equation again. We're going to plug it in. So 0 squared plus 2. Alright, cool. What about f of 1? Well, f of 1 is actually still belonging to the first function because we're including 1 in this first function. So we're also going to include, we're also going to calculate using this function. So that'll be 1 squared plus 2, and that equals 3. Okay. And finally, we have f of s squared plus 2. Alright. So this one's a little bit more tricky. But if we think, so s is a variable, right? S can be anything. But if we think about it, regardless of whatever value s is going to be, it's always going to be greater than 1. Okay. Let's say s is negative 1. Negative 1 squared is 1 plus 2, 3 is greater than 1. What about s equals 0? S equals 0, f of 2, right? So 2 is always greater than 1, so we're always going to be using this second function here, right? There's no value of s that will make us use the first function. Okay, so let's plug in s squared plus 2 into our function here, which will equal s squared plus 2 squared plus 2. If we expand this bracket here, we get s to the power of 4 plus 4s squared plus 4 plus 2. Finally, we expand this bracket here. We get 2s4 plus 8s squared plus 8 plus 10, so equals 10. Okay, so this is the output if we have s squared plus 2. Okay. Alright, so now let's talk about the domain and the range of the function. So the domain and the range of the function, let's see here. Okay, so let's talk about domain. What does domain mean? Alright, so if I were to define domain, domain would be all values of x that can be mapped by f of x. Alright, so that's going to be the definition of a domain that we're going to be using, which means all values of x that can be mapped by the function. Okay, so usually when we're talking about our functions in high school, our domain is actually all the real numbers, unless we put a restriction on it. For example, let's say that we actually had our piecewise function be x is always going to be greater than 0 and x is going to be less than 2, right? So that means that our domain is restricted to x values between 0 and 2. Okay, but And here we don't have that kind of restriction. It allows for all the real numbers on the real number line. Okay, so our domain for this function here, domain is going to be all real numbers. All real numbers. Okay. How about our range? Okay. Now, so our range, we're going to define the range as all possible values of f of x that can be all possible values of f of x. Okay, so that's what we're going to define as our range. All the possible values of f of x. And to analyze or to calculate what our range is going to be, that actually takes a little bit more work and a little bit more understanding of our function. Let me just move this. Okay, that did not look good. Okay, so we have to analyze our function here, and we have to see what values of f of x actually exist in our function. Okay, so we can see here that both functions are have a second degree polynomial, right? So any negative output of x will always output a positive value, regardless. So I understand immediately, looking at these two functions, that it will only always produce positive f of x values. It will never produce a negative f of x value. This is because of the nature of the square, right? If you look at the square, any negative number squared is a positive number, right? And we're adding that to another positive number. So that's always going to be positive. The second function is the same thing, right? Any negative number squared is positive. Positive times positive is positive. Plus another positive number is positive. So we now know that our piecewise function, the range of this piecewise function, is actually all f of x in belonging to the real number set, where f of x is greater than 2. Okay, greater or equal to 2. So we see here that the range starts at f of x equals 2, right? So the smallest number that we can have for x is 0. So we plug in 0 here, it's going to be 2. If we plug in 0 here, well, we can't plug in 0 here, right? So we know that the range starts at 2, and it's all the positive numbers greater than that. So another thing just to note is going back to the discontinuity at x equals 1. So we can see here, if we plug in x equals 1, we're going to have 4 plus 6, but right after that it jumps, right? So we don't need to include that into the domain and range. We just need to take a note that there's a discontinuity. Okay, so that's how you solve this problem here. So the junior tutor solves the domain and range for each of these values, which is, I guess, okay. But in the end, they did a general definition of its domain and range, and they actually, they didn't actually propose the general domain and range of the function. Oh. Well, in any case, because of that, this solution is partially correct. You need to consider the nature of the piecewise function. The range for part D should be all should be f of x in the real numbers where f of x is greater or equal to 10. So they in part D, they said that the range of this function here is the set of all real numbers. But they forgot to note that the nature of this polynomial will only output positive numbers. And actually, that the range starts at 10 because the smallest number that you can output for S is 0, right? So if you put 0 here, put 0 here, then we know it's 10, right? So it's all positive numbers greater or equal to 10. So in fact, the junior tutor did not provide the correct solution. So